So I'm going now to show a circuit that can drive the ultrasonic transmitter. The need of a driving circuit emerges from the fact that usually a microcontroller pin is too weak or cannot have the enough power to drive an ultrasonic transducer. What is an ultrasonic transducer? Electrically, it can be simplified by a model. This model looks like the one shown here. It's basically capacitive, but also the other parasitic um, values are also included here. I'm not going to go into how do you model the transducer, why the choice of those components, but suffice to say that the main value of the capacitance of the transducer can be found in data sheets, like for example what you would find here. This capacitance is measured at a certain frequency, 2400 picofarads is the value. The one model I'm using here is slightly different from, or it's of another transducer. Those values I got from a data sheet of a Morata 40S4R. Mine is nevertheless a little bit different. It's this value. It's this um, uh, it's this transducer used for transmission, and Mm, so my driving circuit has to be able to switch at 40 kilohertz. 40 kilohertz is again the resonance frequency of this transducer, which is a common value, and my driving circuit has to be fast enough, be able to deliver enough power to this transducer. So there are many ways to do it. The way I would like to do it is through using what is called a tandem pole, consisting of this Q2, this NPN transistor here, and this PNP transistor here, and the driving circuit Q3 along with its components. The input is a PWM signal that is running at 40 kilohertz at the resonance frequency. So if I am going to show that signal, um, this is how it looks like. An on time where the voltage is 5 volts, and off time where the voltage is 0 volts. This is coming from the microcontroller, and the voltage I'm using to drive the transducer is 12 volts. The higher the voltage, the more your ultrasonic signal can go, or the further it can go, but you have to be aware that it has an upper limit, and that is the maximum driving voltage given here in RMS. So 20 volts RMS should not be exceeded. Of course, there's a calculation factor that relates the RMS value of a PWM signal with that of a DC signal. Okay, so how does the circuit work? I'm going to go here and say, so when the level of the PWM signal here is low, that is 0 volts, what happens is this transistor is switched off, and that being the case, then the 12 volts supplying this transistor and at its collector and its base would lead to this transistor being switched on and current flowing over this direction into the sensor, and almost 12 volts being provided here. This leads to and being also switched on here, that forces Q1 to cut off, or to be switched off. You can consider Q1 to be an open circuit, and this results in the current being sunk into the transducer. Okay, well, if now the voltage at the PWM output of the microcontroller is now um, is 5 volts, or high, let's say it's high, then this transistor will switch on, and doing that it will sink current into this direction, and the voltage here will drop across the 10 kilo ohm resistor, and this will force this transistor to switch off, with the base voltage being lower than the voltage of the emitter. The voltage of the emitter comes from the fact that you have charged a capacitance here to 12 volts previously, and that value holds on a little bit, or for a long time actually, neglecting any discharging resistances. This transistor, having its base emitter junction reverse biased, will be switched off. So you can consider this one to be um, an open circuit, and with 12 volts being here, 0 volts almost being here, or it would be a little bit higher, but this will lead to the current to flow over over the emitter collector junction, and slightly also out of the emitter base, in this direction, and that means you are discharging the capacitance, and the voltage here would drop, and it will eventually reach almost 0. So if we would like to see this in the simulation, we just we don't need to run it again. We just display we display this signal here, and it shows just that when the end result is, when the PWM is high here, uh, you have a low voltage here. When PWM is low, then you have a high signal here, or a high level of voltage here. Of course, 12 volts. This is the red signal shown here. This way you are running at 40 kilohertz, and you are causing the transducer to resonate at that frequency and emit the ultrasonic signal output, and this is how the circuit works. Well, I've done some lab measurements, and the simulation is coherent with the results. So the channel 1 is the microcontroller's output signal, PWM signal, having 5 volts almost, I think. So 1, 2, 3, 4, yes, 5 volts peak to peak is the level, and the blue signal is the signal at the transducer, or at the ultrasonic transmitter. So this looks good, and I will now continue with explaining the reception or the receiver circuit, and how it works before I show online how the whole system works to measure the distance of an object. Yes.